Imagine you're a data scientist working on a machine learning project. You need to train a model, but not just once. You have to run hundreds of training jobs, each with different parameters, data sets, or configurations. If you're doing this manually, it's going to be a nightmare. If you're writing some scripts and chaining them together, it's going to be too messy. If you're running them on a single machine, it's going to be way, way too slow. Hi, everyone, and welcome to the 10th episode of Argo Unpacked. I'm Revital, and I'm super glad to be here with you, Dan. You're muted.
Thank you, Revital. Thanks for that wonderful intro. That's perfect.
Yeah. And together, Dan, we're hosting Sebastian today, who is going to share some great insights and tips about Argo Workflows.
That's right.
Yeah, hi everyone. Thanks for having me.
Sure. Awesome to have you here. It's going to be a good one. I'm excited. It's our 10th episode.
So before we get into Argo Workflows, and Sebastian's going to share with us their use case, what they've been doing. We'll talk about some general use cases. We do want to cover a couple of items of Argo news. We always do this at the top of the show, and then we get into our kind of longer topic. So first thing to bring up is the state of GitOps report. And let me pull it up. So the state of GitOps report just came out, and Steve Fenton really led the charge on this. I'm a co-author on it. We interviewed 660 people, and it is really powerful. Some of the insights that we took, one that I took away is that when it comes to DORA metrics, those metrics that measure the productivity of our software delivery, adopting GitOps fully was one of the most impactful ways to improve your DORA metrics. Actually, high performers on high adopters of GitOps actually have twice the performance of low adopters of GitOps. And if you follow the DORA research at all, you'll know that that is one of the largest impacts that you could possibly see. So definitely go and download that report. We'll throw that link in the show notes for people listening on the podcast, and we'll also throw it in the chat for people that are watching live. And then going into other news, we also have this week.
And may I ask just one question?
Shoot.
Is it the first ever state of GitOps report that is actually out?
Oh, that's a good question. I think
it is.
It is the first one, yeah. Yeah, we've done the surveys for Argo CD before, and we've done some surveys related to GitOps before, but this is the first state of GitOps as like an industry-wide state report, yeah.
Okay, I'm gonna add the URL.
Okay, perfect, thank you. So yeah, definitely take advantage of that if you can. Another big landmark thing to talk about is the release candidate for Argo CD 3.1 has been made available. So if you are an early adopter or you have a test cluster, go and test this out. Share your feedback. 3.1 has a couple of really powerful features. Christian was the release champion for this one. So I think many people will remember Argo CD 3.0 was the small but mighty release because it had a lot of changing default behavior and really set the stage to make it easier for us to make a lot of really big improvements. So 3.1 is the first release that really starts delivering on that. We've got OCI support coming out in beta, which is a really powerful feature. We've got CLI plugins. We've got Hydrator improvements. We've got UI improvements. And OCI, just to take 1 second on OCI, OCI is the Open Container Registry. This is a format that is used for storing Docker images. It's now used for storing Helm charts. We used to have Docker registries. Now we have OCI registries that can handle Docker images in addition to other things. And of course, Argo CD has had support for manifests stored in Git or Helm charts stored in either an OCI registry or a Helm chart repository. But with OCI support, you can actually have general Kubernetes manifest bundled into an OCI object, and you can just reference that and pull it in. And this supports a way of thinking of software delivery typically as binaries, which we've kind of moved away from with Kubernetes because the binary was really the image, and then you had all your configuration that went along with it. So this allows you to package a new version of your rendered manifests, push them to an OCI registry, and then pull those. So that's a pretty big sea change in the way that people maybe have been using Argo CD outside of this. So 3.1 is currently a release candidate. We'll probably go through 1 or 2 more release candidates at least. We typically do 2 or 3 before we get to a final version. So if you have a chance to install this, maybe on a test cluster or a staging cluster, and see any behavior, please flag that for the team. We'd love to have that feedback and get those bugs worked out before we move into a final release. And then another item before we'll talk about workflows in a second, but Rovital, I think you had a special win in Argo CD.
Yes. And I think I was super excited about it because we had Alexander talking about scaling Argo CD. And then he was mentioning some default values for the default app resync period jitter, that it's 60. And while he was talking, you were looking at the code and you're like, we changed the code, but we didn't really change the documentation. So I opened an issue and I was also able to fix it. And I was super excited about it because thanks to Argo Unpacked, this PR was merged. So we really encourage everyone to take a look, to watch, and to fix issues.
It's like so perfect that we could combine the time we use to record this podcast and do the live stream with actually making fixes to Argo.
Yes.
It's rare that you have time to do both at the same time. And congratulations on your commit. You've made a handful of commits at this point to Argo CD, so you're well on your way to doing more. Great work there and great win for the show. And thanks for celebrating that with us. Now to Argo Workflows 3.7. Now on this show, we mostly talk about Argo CD, Argo rollouts. Those are the areas. I'm an Argo CD maintainer. I contribute sometimes mostly to documentation on rollouts, but I'm not a maintainer on that project, though Costas is. But we don't talk too much about Argo Workflows. So Sebastian is going to be the one to be the expert today because I've used Argo Workflows. I definitely have done some debugging on Argo Workflows, but I definitely don't think of myself as the expert on Argo Workflows. So we have Argo Workflows 3.7, which the release candidate 3 just dropped about 2 hours ago. So I think you had a chance to review a little bit of the changelog, Sebastian. Any features that you're excited about you want to tell us about?
So I had only a quick glimpse through the changelog, but I think the smarter caching and memorization features are quite nice because you don't want to do everything twice. And so having a better way to memorize already existing results is always quite helpful. And we rely also on some of our workflows that we only memorize results. And also having a look at this dynamic namespace parallelism also sounds quite nice because we have some things that run in different namespaces, and we always were bound to having everything in one config, and we could only specify parallelism on a global scale. And so having a more fine-grained control by namespace, I think it's quite a nice improvement for having multiple different tiered workloads that need to have different priorities between each other.
So, Sebastian, do you have a standard way of how you adopt updates to Argo Workflows? Do you just take it when the final is done? Do you test release candidates?
Most of the time, not. So I always give it a few days or maybe even a few weeks when a new release is out, because sometimes there will be rather quick fixes and updates, and there will be a 3.7.1 or something like that, because there was one thing that got missed. And so because it really depends. We have multiple instances running, I think a dozen or so. So there are few instances that are not that mission critical, and they always are the pathfinder in this regard to see and look if everything works fine, and afterwards I can update the mission critical ones.
Well, perfectly highlighted. Go check out the new blog post for Argo Workflows 3.7. We have 24 new features, 82 bug fixes, 70 contributions total from 39 new contributors. and great work leading that from Ishida, who does a lot of work on Argo CD as well. I don't know if she led this release or if she just did the blog post, but either way, impressive from from the standpoint of doing two things at once. So I think we've covered the big news for Argo CD this week. So we're ready to jump into today's topic. So Sebastian, before we jump into some of the content around Argo Workflows, would you share with us what your Argo Workflows setup and experience is like? Because you actually have a fairly unique scale, I think, compared to most organizations that are doing workflows on a smaller scale than you are.
Yeah, so maybe to my background, I'm working in a university in Germany, and so in this university we have quite unique opportunities so that we manage a community cloud for researchers in Germany. And so the German government gave us a lot of money to put some metal in the cellar, and we run mostly Kubernetes, but also VMs and all kinds of stuff on this. And so we have quite a few topics where we want to use workflow engines for scientific compute. And in this regard, Argo Workflows, because we already had Kubernetes clusters in place, was quite a good fit. And so this was the story how we came to Argo Workflows. I think it was 5 years ago or something like that.
Yeah, and I think you mentioned to Rivital and I that you had, what, 4,500 vCPUs?
I think more. I think now it's almost 10K overall clusters. I think the largest cluster we have around 6K or something like that.
Oh.
And so having a 6K cluster is when we talk to people at KubeCon about this, they always look a little bit confused because they think we are CERN or something like that. Because
yeah.
I think these are the only other people that do some crazy stuff with Argo Workflows in this regard.
Yeah, CERN famously will use Argo Workflows quite heavily, and they will exhaust in the past. Now that AI is on the scene and GPUs have really ramped up, but in the past, I think they actually exhausted all of the GPUs on both Amazon and Google Cloud for a single experiment data crunching that they were doing. So similar, a little bit of a different scale, but yours is actually on-prem, it sounds like. I didn't realize that it was all metal in the building that you have.
Yes. So it's not only in our building. We are a community with 7 locations, and throughout these 7 locations, I think in total we have around 120K vCPUs and a few hundred GPUs, and more to come because now everyone is doing AI and the need for GPUs is quite high. But it was quite hard to get some because buying GPUs is quite tricky currently.
Oh yeah, no, you got to know somebody. When I built my AI box back here, I put 3090s in it, and it was definitely like an eBay, combing, looking for stuff. But that's a different scale. I needed to buy 2. You guys needed to buy, 300 or whatever it is. So it's a whole different problem.
Yeah, if we go to NVIDIA and say, okay, I need 300 H200 or something like that, then I don't know. B200, I think. I don't know what the latest ones are. I think it's either on one side it's quite expensive, and on the other side it's always, it needs months to get to them.
Yeah,
because there are huge people that buy hundreds of thousands of them, and so yeah.
Guys, I want to represent the newbie voice of this discussion. Do you mind if we'll go a little bit backward? And for anyone who is really new to this, what is Argo Workflows and what kind of problems it is designed to solve?
Sure. I think the best description for Argo Workflows, it's a workflow engine. So if you have a problem that needs to calculate something or needs to do something in a containerized way in a sequence, then Argo Workflows is the perfect fit for that. So if you have some preparation tasks and some compute tasks and maybe some finishing up cleanup tasks, and you want to have a workflow that stages all these steps one after the other, I think Argo Workflow is quite a good fit. And use case, like, it's quite broad, from advanced CI/CD stuff to machine learning to ETL pipelines. I think there is quite a few opportunities to use Argo Workflows if you have a Kubernetes cluster already in place.
Yeah, data processing. The thing that really sets workflows apart in my mind is that you can take advantage of resources across many nodes, because you can link together all these pods, and that's unique. Like, if you just want to run a workflow, hey, I could run like a Kubernetes job, or I could run a bash script, or I could use Jenkins, or I could use GitHub Actions or whatever. But none of those things can take advantage of like 10,000 CPUs, which is something you could do with Argo Workflows. And I think, Sebastian, you actually had shared that one of your largest Argo Workflow was something like, it was thousands of pods, wasn't it?
I think it's tens of thousands of pods. I think the largest one are 30, 40K or something like that. And then you need to make sure that you don't run them all at once, because you will overwhelm every scheduler on the world with 40,000 pods at once.
Yes. So this is perfect timing, Ravital, that you brought this up, because someone in the comments is asking what's the difference between workflows and Argo CD. Thank you, GeoCloud Tech, for that. But so Argo Workflows, I think Sebastian covered it. Argo CD, on the other hand, is a tool for deploying to Kubernetes. And so what you can do is you can have your Kubernetes manifest sitting in a Git repo, or we just mentioned, in an OCI repository. You can then specify what Kubernetes cluster, what namespace you want those deployed to, and it will keep them in sync. And the reason that these tools are related at all, it actually started with Argo Workflows. So originally the project was just called Argo. It wasn't called Argo Workflows. And it was all about sending workflows, basically pipelines, into a Kubernetes cluster so that they could be leveraged for data processing, ETL pipelines, CI/CD, whatever. And as the team was working on that, they said, gosh, we need a way to get these workflows that we've defined onto the Kubernetes cluster. And so that's where Argo CD came from. With the introduction of Argo CD, Argo was renamed to Argo Workflows. And so we have Argo Workflows, Argo CD, and then later it was Argo Events that joined, as well as Argo Events was, I think, donated by BlackRock. And then Argo Rollouts was the fourth main project to join before we moved into like the CNCF graduation process.
I did not know that.
Oh, yeah. Okay.
So it was Argo so Argo was actually Argo Workflows. Oh, yeah. Wow. Interesting. That's a great question.
Argo Workflows is very popular. It's in use by tons of organizations. Argo CD has been even more popular. So Argo Workflows is super successful. If the entire project was just Argo Workflows, it would be a very successful CNCF project. Argo CD actually ended up being more popular, and that's where we spend a lot of our time focusing, coming from CodeFresh, Octopus Deploy. But we actually, Sebastian, in CodeFresh, we actually leverage Argo Workflows. So when you use our GitOps promotion tool, it's actually using workflows as part of the backend to execute those pipelines and look for approvals or run tests or whatever. And so when you're building your process engine to do a promotion from one environment to another, and you're doing diffing and you're making commits, that's all running on Argo Workflows. So we do have definitely the experience with Argo Workflows. Just I personally am more CD and rollouts oriented.
So I think one important thing here to note is that Argo Workflows doesn't really need to run pods in a Kubernetes cluster. It can also put any other Kubernetes resource in the Kubernetes cluster. So it can be used as poor man's CI/CD pipeline, but you always lose the whole Git functionality from Argo CD. So I saw some people that had a more advanced build step and in the Kubernetes cluster itself, and then deployed it right away with Argo Workflows and put the whole workflow in Argo CD. And then you had the best of both worlds, I guess. And we also have some use cases where the last step is create a deployment that presents the results from a scientific computation.
Well, that brings up a super common issue, which is that because Argo CD's popularity with deploying, a lot of people hear that Argo is good at deploying software. So they go to the website, they go to argoproj.github.io, and they see workflows, CD, events, rollouts, and they say, what thing looks the most like CI/CD, which is how I've been deploying, and they click on Argo Workflows. And so a shocking number of people show up at the Argo project and start using workflows to build CI/CD pipelines because they've heard, hey, this is great for deploying. And so they'll build their CI/CD pipelines into Argo Workflows. And I actually had this experience with a company where I came and did an architectural review with them, and they shared with me this really impressive Argo workflow of workflows that they had built to manage all of this CI/CD orchestration. And they were building their containers and the whole shebang. And when it came to the deployment part, I kind of listened and I said, wow, that's pretty cool. You built all this. It's amazing. Why didn't you use Argo CD to do that? They said, we're not really familiar with Argo CD. And it was this kind of light bulb, electricity in the room moment where it was like, well, here's what Argo CD is good at. And the team said, oh, okay, we actually built too much with Argo Workflows, and we're gonna migrate this part over to Argo CD. Now they're still using it for doing CI work, for doing CI/CD work, but they're using Argo CD to do its part that it's really good at, and they're letting Argo Workflows do its part. So Argo Workflows definitely works as a CI/CD tool, and there have been some features added. But I'll tell you, Sebastian, you started 5 years ago using Argo Workflows, and at the time, I remember the main contributor, the lead for Argo Workflows was Alex Collins, and we were at a KubeCon together in the Argo booth. And people kept on coming by and telling him how much they loved it for CI/CD. And he kept on saying, why are you using it for CI/CD? We didn't build it for that. Like, what features did you take out of this that you thought this would be great for CI/CD? And he was baffled by it. But of course, it has been a popular use case, and a number of features have been added to make it better for CI/CD. So it is definitely a viable option.
So, Sebastian, I know that there is a wide range of workflow tools, and I know that you guys used several of them and then needed to either migrate or integrate to Argo Workflows. Can you highlight why did you guys wanted to move and to do so much work and use Argo Workflows?
Sure. I think the main problem here is academia, because we have a quite high turnover of people. So people come and go, they write their PhD, and then they are gone. And we don't really have that heavy restrictions on what tools they have to use. And so everyone can use their own stuff. And this quite often leads to a quite fragmented space where everyone brought their own ideas, and everyone read something about this nice tool, and Spark is the best thing to do to compute, and other people had Airflow or other tools, and then we had the huge problem that we had all this legacy stuff lying around, and all this workflows that are already in place, and maybe they were containerized and running Kubernetes, maybe not. And so then we came to the idea, okay, maybe we should reconcile this, and maybe we should unify some of these tools and put it into one thing, like Argo Workflows. And so then we looked around and tried experimenting with this, because I'm a bioinformatician, and so people in bioinformatics love workflow engines. I think they wrote 50 over the years, and so everyone has their own crude way of doing workflows, and so sometimes it's a little bit annoying to consolidate that, because one problem there is most of these workflows we have lying around are one-time project. Someone does their research, does their science, writes a paper, and then it's gone. But once in a while, there are some really popular workflows and really popular tools that we need to keep running, because even if the main developer is long gone, and is already working in a company or something like that, we need to maintain their stuff because it's popular and people from the research community use this. And so we have quite a high burden from a technology standpoint to maintain this. And so the one idea was to migrate as much of that to Argo Workflows, or at least integrate it, so that we have one place to look for running compute, running jobs, running stuff, so that we can see, okay, here is something running, and there's something not running, and we need to fix it. And so this was the idea overall. Can Argo Workflows be a universal scheduling engine for compute workloads? And I think the answer is most of the time yes. So there are always some specialities and some special stuff where it's a little bit annoying. So real time is always quite problematic with Argo Workflows. So it's more a batch compute way to handle stuff. So you have some input data, do something with it, and have some output, visualizations or whatever, and then you want to present this to some of your users. But I think for many of the use cases we are dealing with, they're quite easy. They are mostly formulated in a few Python scripts, and so running Python scripts in sequence is really easy. And with tools like Hera, the Python library for Argo Workflows, it got a lot easier for people that don't really like YAML and writing YAML definitions for their workflows, when they just want to write a simple script that does something.
Yeah, and it does seem like Python has cemented its place as being the way to handle not only like data pipelines, but anything AI, anything ML. I saw somebody was talking about maybe migrating some of PyTorch into Go, and it was just like everybody was just like throwing rotten fruit at it. They were just like, we hate you for doing that. Just keep it in Python. It just seems like Python just won that battle and has cemented itself as an incredibly relevant language for decades to come because of that.
Yeah, so the data science world is using Python, and I think there is not really a way around that. And yeah, I think with tools like Hera, it got a lot easier to do Argo Workflows with Python as well. And we had some examples. There is this, maybe I can, if I can find the slide, I think it's somewhere here. It's quite, is it this one? Yes, there's also this this tool called UV, and UV is a modern alternative to pip, and it allows people to write inline comments in their Python script that does all the dependency resolution. And this is quite nice, because then you don't need to have an environment prepared where you want to install all the libraries you need. You can just say, okay, resolve it for me, and then you get a nice Python script that in place has all the dependencies resolved. And we made quite good success with that. And we had
Is that a common pattern? I haven't seen that before, where you write a script in a comment and it is used for something like dependency manager or anything else. Is that a pattern from some other programming language? Where did that come from?
I think it is a little bit a pattern in some of the frameworks that are for serverless stuff and serverless compute, because sometimes you need to define your dependencies for your tool or for your programming language and where to put it. And the best thing, if you have only one script that needs to run, is put it in the script itself and define what the script needs. And so I think it's quite a unique and new pattern, but we had good success with that. And because dependency resolution in Python is always a problem. And sure, if you want to run this a bajillion times, then you want to build your own container that has everything already in place. But if you want to run this a few dozen times, it doesn't really make sense to build a container for that.
Yeah, that makes sense. Yeah, that's an interesting pattern. I don't know if I like that. That putting stuff in the comments. I'm like, no, comments are where you make comments and you make a mess and you provocate you you provocate. What's that word? Provocate? I can't remember what the word is. Anyway, you talk BS. You spam a bunch of random stuff. The idea that it has programmatic import makes me fear. I'm afraid of that, but it's interesting.
Yeah, I think there is a unique syntax where you put this in the top of your file, right under the shebang, and then it gets resolved automatically. The main point here is that UV is lightning fast to resolve the dependencies, so it only makes sense if it is quite fast to resolve that and to install your environment. It doesn't really make sense if it takes 10 minutes to build your environment, because then you are always better with building a container once and for all.
And where were your before adopting Argo Workflows? Where would you run this stuff?
So we are always running, or we are now also running Slurm clusters. So Slurm is for academia, I think the last 20 years. Before we had a Sun grid engine, and so some grid compute is always running in academic clusters. But the problem with the one large cluster is always that we need to share the resources, and there's always one job that needs all of the resources, and everyone else has to wait. And running containerized workloads in a Slurm cluster is also quite annoying. Not impossible, but always a little bit finicky and annoying. And because we also have Kubernetes lying around, and most of the time we have some use cases where we want to deploy the results to a Kubernetes cluster to expose it to our researchers. So a researcher triggers a job and says, okay, here's my input data, and afterwards I want to have a fancy visualization, and there it is quite good to have a Kubernetes cluster on hand, where the last step is make a deployment and expose it via an ingress, and then the user can get a link, and the link has everything in place, what they have done, and they can interactively explore their results.
So it's actually about the UI as much as it is about the data pipelines.
Sure. I think Argo Workflows is also quite good at having a visualization of what is running, because you don't really have that for Slurm. You need to use your command line and put some commands in there, and they are always a bit magic, especially for biologists, and because they are not really that familiar with command line tools, they most of the time want to have a one-click solution that does everything for them. And so we wrote some tools that are just a thin wrapper around Argo Workflows. So you have a website with an API, and the API just calls the Argo Workflow API, does some compute, and afterwards comes back and says, hooray, your results are there, and here you can see what you have done, or what your data looks like, and what maybe insights are in your compute.
Yeah.
So, yeah.
With Slurm, because obviously Slurm has been around for a long time, is there a good way to bring Slurm into workflows? Like, because here you were talking about leveraging, like having Slurm, like, okay, go ask workflows to go do some project for me, give me the output of it. In that case, you're using Argo Workflows as a step to do some compute or processing. But what about if I just wanted to take what I'd done in Slurm and like migrate it into Argo Workflows? Is that something people are doing?
I think it's most of the time you don't really use Slurm itself. You just use Slurm as the executor for your workflow engine that runs on top of Slurm. And these are, at least for our clientele, they are most of the time just Python scripts that run in a specific sequence. So putting a Python script in an Argo workflow is trivial. The one thing that is a little bit annoying from a Slurm perspective is Slurm has the feature of one centralized, or can be configured to have one centralized data storage. So one shared file system between all the nodes, and you can put everything in the file system and get everything back out of the file system. And this is not really that. It's possible in Argo workflows. You can have a read-write many volume to do this, but it's not really the recommended way. You want to have
not efficient, right?
No, because IOPS are horrible by any means for any NFS or whatever you're running between your nodes, and so you want to use something like S3 or cloud storage to put your data and get your results back.
Yeah, when we built CodeFresh CI, one of the first things that we did was we would basically provision a local volume to the node, and then we would take that volume and we would package it as a Docker image and store it in your OCI registry, and then we would use that as a source of cache. And for people that were coming from like Jenkins, and maybe they were using Jenkins on Kubernetes, they would have a S3 bucket typically mounted, and they would do all their IO between steps into that S3 bucket. Well, migrating into CodeFresh CI, they would see this like, 70x performance improvement, where suddenly their IO is amazing because they didn't have to use that shared volume. So there's just such a performance penalty when you have to go to those shared volumes over, like I've got a high performant SSD on a single node. That's going to be really, really fast. But when I need to push to the network, it's going to get dramatically slower. And the challenge the challenge with CodeFresh CI then was all of the performance benefits were oriented around a single node. And that meant that when you wanted to do the kind of scale that you're doing with Argo Workflows, you really Argo Workflows is the only game in town for taking advantage of so many nodes of resources in such an efficient, effective way. So in your case, is the storage, you mentioned you generally just use an S3 bucket typically for moving stuff around, but then you just keep as much IO data processing in a single step as you can. So you don't have to move as much data.
Yes, so we try to not move a lot of data around, because moving data is always quite costly. And so sometimes the steps get bigger with that, and this is a little bit annoying, because then we have some some steps that run after the other. There's also this concept of task sets, where you have multiple tasks that run after the other on the same node. So then you can use the shared storage on the same node and at least make use of the SSD. And yeah, so using a read-write many volume is not really recommended, especially not if you run thousands of pods simultaneously that want to access that, because your IOPS drop down to 0.
Yeah.
So
that queue gets really long, and you start getting maybe some conflicts, maybe people fighting with each other. Yeah, that's a problem. In your case, when people are using the Argo workflows for their data science work, for biology work, for whatever, are they typically doing one-off workflows, or are they using the same workflow? Maybe they're using the same workflow template over and over again and changing the parameters. But like, I would imagine that a lot of these things are, I'm going to do some big data processing thing, and I'm going to come back with results that I'm going to then go and analyze into my paper. I'm not going to run that every day. So you're seeing less of the same workload. Is that the way it works? You have a huge diversity of kind of workloads like that.
It depends. So some of our use cases are there in the beginning. They were more experimental, and sometimes they don't really use any workflow engine at all to just tinker around and look which parameter from which tool will fit to their use case and will produce the best results, because there's still a really high turnaround time when you always want to deploy a new workflow for that. So doing it locally, if it's just a small test data set, it also works quite well. But then in the second phase, where they want to have the real data crunched through, then they will migrate it to Argo Workflow, or maybe even a Slurm job, and then they run it there. So we still have quite a few people running Slurm jobs, because they already have some pipelines in place. They want to. There are also sometimes a little bit problems with regulations, because you need to run the tools on a specific instance, and then you can't really migrate it that easily, especially for medicine research, because then the whole pipeline needs to be certified and all this kind of stuff. So then you can't really migrate it. You could trigger it. So we experimented a little bit around with triggering a Slurm workflow from Argo Workflow, and there are also some projects that try to bridge Slurm and Kubernetes. So I think the SCADMD people, I at least heard in a talk at KubeCon that they are working on some bridge technology that tries to bridge Slurm and Kubernetes. But I don't know how far they will get there, because I don't know. I would prefer using only Kubernetes, but maybe this is just because I'm the Kubernetes guy in our community.
I mean, it has a lot of advantages, but I definitely, it's not for every single use case. There are use cases where Kubernetes isn't the best fit, but I do feel like increasingly I find more and more use cases that it's better for. When you want to host just a website in an S3 bucket, don't use Kubernetes to do that. Just put it in the S3 bucket and call it a day. But when it comes to any of this kind of stuff, it's definitely pretty nice to take advantage of Kubernetes.
I think. Okay, sure. Go ahead.
I remember you mentioned that, and now that Dan is saying don't use Kubernetes for every workflow, for real time and low latency responses use cases, will you say don't use Kubernetes or don't use Argo Workflows, or both?
You can use Kubernetes for this, but you need to have a pod that's already deployed that's responding to your request. So then it's totally fine if you have something that has an own API or something like that, and then responds to your needs. Then real time, I think, works. It depends on your requirements for real time. It's always a little bit fuzzy if you need milliseconds or seconds or whatever latency you require. If you have a strict latency budget for running Argo Workflows, I think Argo Workflows might not be the best tool for you, because spinning up a pod, even the smallest pod on the world, it always takes a little bit of time, because you need to find a node and then it gets scheduled there. And depending on the size of your cluster, it can take a few seconds, or most of the time will take a few seconds.
Oh, that made me. I had a question actually about that, Sebastian, because it stuck out to me that you mentioned that you're doing all this bare metal Kubernetes in your organization. And in CERN's case, they're taking advantage of cloud resources. And part of the reason that they use workflows is because they can go and provision 20,000 GPUs to throw a workflow at, and then they can spin them all down and let it go back to the cloud. So they're not paying for it. In your case, because you have all this bare metal, it's probably more about horse trading between organizations that are currently taking up resources. So how do you manage the queue for these workflows from a performance standpoint?
So most of we are not running Kubernetes on bare metal itself. So it's still a virtual machine because it's way easier to manage virtual machines on top of bare metal, because we use OpenStack for that. It might not be the best thing to have, but it's the best to have for open source work. And so most of our projects have certain quotas on a VM perspective, so they can have up to X amount of VMs, and then we use most of the time a cluster autoscaling for that. So if we have some clusters that are not used, then we try to scale it down to bare minimum and scale it up if we have a new workflow running. It takes some time to provision new nodes, and but then everyone gets to do something with the resources. And so we made quite good progress and had quite good success with cluster autoscaling, even if it takes 10 minutes to provision a new node, because when we have workflows that use 50K pods or something like that and run hours or days, or even I had some workloads that run weeks, then the 10 minutes doesn't really matter, because it will run for weeks. So if it runs for a week and 10 minutes, it is no real difference there.
Yeah, I think if you need low latency, you can have maybe hot start pods or something available, so you can get that, a quicker turnaround time. But you're right, when it's a 7-day long running workload, 10 minutes doesn't really make any difference. Have you experimented with vCluster at all for resource management?
A little bit, but the problem is our whole network is now quite dialed into OpenStack, and there are also some long-term support contracts regarding that. So migrating to something else is not really an option for us.
You wouldn't be migrating from OpenStack. You would still use that layer to manage your VMs. I was like trying to figure out how to say VM. It was like VirtualBox. I was like, no, not VirtualBox. You'd still use OpenStack to do your VMs and stuff, but you can actually, with vCluster, you can create virtual nodes now. This is a new feature they announced a couple weeks ago. So you can create virtual nodes for these clusters, and they will they actually go and operate on your VMs at the level of what's that called in Linux, when you have like separate like the Linux namespaces. Yeah. So you can actually get this really impressive security bifurcation at the node level, but you get virtual nodes that are available, and you can spin them up, spin them down super easily, so you can take better advantage of the number of physical nodes and virtual machines that you have. I was really impressed with it when I went through this. I was in New York a few weeks ago talking with the vCluster team, and they put out a lot of great work. And this is not a paid endorsement or anything. This podcast brought to you by vCluster. No, they didn't pay for that. But I do just am continually impressed with what they come out with. And the fact that in your case, where you've got all of these different teams taking advantage of the same physical nodes that have virtual machines on top of them, to be able to take advantage of those virtual machines more efficiently using something like vCluster, while having the security and some of the certified environment stuff that you have. I feel like it could be interesting. Might be worth checking out.
It might be, but I think the main problem here is that we quite heavily rely on separation of concerns on a VM perspective, because VMs are always a little bit more secure than having a shared environment. This is the reason why we don't have really that many shared Kubernetes clusters. So we just spawn a new Kubernetes cluster if someone has a specialized need. And we use I don't know how it's called, cluster API. Is it cluster API?
Yeah,
I think
API.
We use, I think, Kubernetes for that, and they just spin up a new Kubernetes cluster, and since we only have virtual control plane nodes, they don't really take up that much space, and so we can just spawn a new VM to do number crunching and put it in a new Kubernetes cluster, and we have separation of concerns from this regard. And also, quotas are always a little bit annoying there, because our whole quota system is built around OpenStack quotas, and so
oh, right.
So when a researcher comes to us, they have to apply for it, and they say, okay, I want to do this, and I need these resources, and then there is a committee that approves it or denies it, or says, okay, you need to change something in your request, and then they get the resources practically for free. So they don't have to pay for it because the government has paid the bill already, and we, as long as we have resources available, we don't really deny any requests that are reasonable and make sense from a scientific standpoint. And then they get a project and can do whatever they want with it.
You mentioned most of these things around in terms of vCPUs, but we didn't really talk about GPUs. Are GPUs part of the equation for you?
Yes, sure. So, and they are growing. So as we talked about a few minutes ago, so buying GPUs, it's always
you did mention that.
A huge hassle, and so we are currently trying to upgrade some nodes with GPUs and also make them available from a Kubernetes standpoint. Because of the whole AI hype, we always have a deficiency on GPUs, and there will always be higher demands for GPUs, because everyone wants to do AI and wants to do machine learning and has their models to train or inference to do. And so GPUs are, I think, our primary bottleneck currently. So if someone comes to us and says, okay, I want to have 5K vCPUs, then go for it, no problem. But if they say, okay, I want to have 200 GPUs, then this is a little bit more complicated to do, unfortunately.
What's the state of GPU management in Kubernetes? Because the last time I went to do this and do some GPU workloads on Kubernetes, I couldn't share GPUs among multiple pods, which was a challenge. I think you can do that now, but what's the general state of just GPU support in Kubernetes? Is it quite a bit advanced from what it was a few years ago?
Yeah, I think it's gotten better, but the main problem is that you need to have enterprise GPUs to have the whole sharing feature to work. And so you need to have the professional GPUs, because the other GPUs aren't really shareable, because they can't be separated in multiple compute instances or between multiple pods. And the main problem we have is that most of our tasks need almost all the RAM of the GPU. It's not really about compute from a GPU perspective. It's more about
you need the memory.
Put the stuff in memory, and so we don't really split up GPUs, because it's too much pain to do so. And we added some lower end GPUs to our clusters for the people that have only small jobs to calculate, and then they just use the lower end GPUs. We also not we personally, but in our network, there were also quite a few instances where they bought, I think, 1,000 4090s or something like that, and just put them in the racks. Because when you don't need to split them, I think it doesn't really matter. And the 4090 from a compute perspective is a good card, but you don't really get support from an enterprise perspective for that. And it's always a little bit of a hacky solution. But I think it's a quite cost-effective solution, because having one 4090, even if it's $2,000 or whatever or now 5090 or whatever, $3,000, it's still a bargain compared to a professional card.
Yeah, compared to an H100 or the newer cards now. Well, is 4090 the lowest end you all deploy hard?
I think we also have quite a few older cards, so A100s and V100s. I think there are also quite a few lying around. They are quite a bit outdated by now, but every GPU matters, and it's better than nothing, I guess.
So you're telling me that the two 3090s I have in this window right here, each one is 24 gigs of RAM. You're telling me this is maybe a little out of date. It's okay, Sebastian. I know you're German.
Yeah.
It's okay to say, yeah, you're out of date, buddy.
I'll jump in and help. I have a question that might help you a little bit, Sebastian.
Yeah, sure.
So we have 4 minutes left. I want to ask you, where do you see the biggest gaps or limitation in Argo workflows?
Great question.
And the reason I'm asking that is because the next question will be, how can the community support and contribute to improve Argo workflows?
Great question. Yeah, I think the main point, or the main lacklustering point, is handling resources and scheduling in a Kubernetes cluster, because the default scheduler of a Kubernetes cluster is quite simple. Let's be real, it's quite simple, and it doesn't really have a notion of workflows itself. So every pod is for on its own, and so if you have multiple workflows running in parallel that have some kind of priority, and you want to make sure that the optimal way is used throughout the Kubernetes cluster, then Argo Workflows is sometimes a little bit lacklustering, and there are works around it. So there is a whole project called Q, which is a more advanced batch scheduling workloads orchestration thing and scheduler for the Kubernetes environment that also supports multiple clusters combined together, where you can have tiered clustering and all this kind of stuff. And so the integration of that would be a huge upgrade to Argo Workflows itself, and it would also I think negate the many pain points people coming from Slurm have, because the main benefit of Slurm is that you have fine-grained control who accesses what and in which order, and if a pod runs too long, then it gets suspended and all this kind of stuff, or if a job runs too long, then it gets suspended and put on a idle queue or whatever and moved around between the queues. And I think the queue job scheduling, job queuing framework that the people are working on is one of, at least from my perspective, so I mostly deal with people that want to do HPC, is one of the things that would be a great addition. And I think there's already ongoing work to integrate this.
Amazing. And we have one non-Argo Workflows related question that was asked. Dan, maybe you want to take this one?
Yeah. What do you advise, to use a bash script to update the image on continuous deployment, or Argo image updater? And I definitely would prefer to use image updater over a bash script. Image updater is a way where you can basically say, hey, watch a Docker image repository for this version pattern, and when there's a new image published, go ahead and automatically update my manifests in my Git repository. It pairs pretty well with CodeFresh GitOps Cloud, though I think I don't know if I've tested that exact scenario, but I would expect it would work really well because of the way that those two tools work. So I definitely would advise that over doing a bash script. You can do a bash script inside, but then you have to do some sort of pipeline somewhere, right? You got to do that in GitHub Actions, a CodeFresh pipeline, Jenkins pipeline, whatever, and you just have to build it. And then, of course, there's always going to be components that you want to update that are outside of just the image tag, which is where GitOps Cloud really shines, because you can compare environmental variables, config maps, whatever. So that's a good one. And then we have a question from Luke. It says, could I treat Argo Workflows as stateless, deploying many instance clusters of Argo Workflows and putting a big load balancer out front, creating a massively scalable distributed CI/CD?
You could do this. I think you can do this. Obviously, you can do this. Most of the time, we prefer to having each cluster with their own Argo Workflows instance because it makes it a little bit easier to manage. But it's certainly a case where you could have one Argo Workflow instance that manages all your instances clusters at once. Both works fine.
Yeah, I mean, the whole point is once it starts to run is when it's going to go and spin up the pods and go and take advantage of it. So that you're using a single instance or multiple instances shouldn't, it's only meaningful insofar as the resources it can then command, right? Because it's not running all those pods when the workflow isn't running. It's only spinning those up when you need them. Yeah, good question, Luke. Well, as we come to a close, thank you very much, Sebastian. Rovital, what do the people need to know?
A lot of things. First of all, we have Argo Unpacked website. It was shaped pretty nicely recently, thanks to our design team. Feel free to take a look. Feel free to subscribe to our newsletter. We're sending every 2 weeks or so a newsletter. We're also having our socials. Follow us on LinkedIn, on X, and on Blue Sky. We also have our YouTube channel where we generate a lot of short videos about highlights of the show. So feel free to subscribe and follow us there as well. In the next 2 weeks, we probably won't have our instance of Argo Unpacked because Dan is going to visit us probably. So yeah, we will postpone that, and we'll probably have Christian on our next episode.
Oh yeah,
we will keep you all updated. Just follow us on social, and you'll get it all.
Subscribe to the newsletter, like you said. Yeah. Cool. Perfect. Hey, thanks everybody for joining us, and thank you, Sebastian, for coming and being our Argo Workflows expert. We'll see everybody next time, and stay synced.